Can your Android device run Linux natively? Maybe. 2 weeks ago I posted a video showing how I reverse engineered an $80 Android tablet and made it boot pure Debian Linux from an SD card. No root, no bootloader unlock, and Android is still untouched. The response was amazing, but after reading the comments I realized that I need to explain the reality behind this. Because yes, some Android devices can run Linux, but no, it's not usually as simple as flashing the Debian on an SD card and pressing the power. Hello and welcome back to my channel. If you are new here, this is the place where I hack around with Linux, embedded devices, hardware, and pretty much anything I can put my hands on. When most people see a cheap old Android device like this one, as you can see, it's a blank tablet without any marking on it. No model, no brand, no nothing. Everybody see e-waste. They see junk. Something slow, locked down, forgotten in a drawer. Well, I see it a bit differently here. I see potential, because I see a screen, a battery, a storage, Wi-Fi, an ARM processor, and a device that maybe, just maybe, can have a second life with Linux.
But before we go further, let me explain what I mean by native Linux. I don't mean Termux, or I don't mean Andronix, I don't mean a Linux container running on top of Android. Those are cool projects and they are very useful, but Android is still the system in control. With Termux you can get a Linux-like user space, you can run commands, install packages, and do a lot of useful things. But you are still inside Android's world. You don't really control the boot process, the kernel, the device tree, or the hardware mapping. Native Linux is different. Native means Linux boots independently, directly on the hardware, as the main operating system. That means I can change the device tree. I can decide how Linux see the hardware. For example, if the hardware allows it, I could repurpose a GPIO that was originally used for something else, like a camera flash, and use it for something else, maybe to control an LED, a relay, or an external device. In Termux, you usually cannot do that. Android still controls that layer. A simple comparison, it's Apple Silicon on Macs. You can run Linux inside the machine on Mac OS, but that is not native. Asahi Linux is native because it boots independently and runs directly on the hardware, and this is the kind of Linux boot I'm talking about here. And to understand why this is hard, we need to look inside the device. This is Doogee U10, and inside it you can see why this is different from a normal PC. Everything is specific to this board. The storage, the display connector, the screen, the touch screen, the Wi-Fi chip, the power management, and the boot process. On a desktop computer, Linux can detect a lot of hardware automatically. On an ARM tablet or phone, almost nothing is standard. So how can my Android device boot Linux? The answer depends on three walls: drivers tree, bootloader, and drivers. Linux needs a hardware map, the device needs to load my kernel, and the drivers need to make everything usable. Okay, let's discuss about the wall number one, the device tree. ARM devices are not standardized like PCs. The Linux kernel does not automatically know when the display is connected, which GPIO controls power, which I2C bus has the touchscreen, and how the Wi-Fi chip is wired. That information is described in something called the device tree. I like to think of it as a hardware map for the Linux kernel. For this tablet, I extracted the device tree from the Android, decompile it, compare it with Rockchip Linux example, and slowly rebuild my own Linux version. This is why the tablet can now turn on the display, detect the touchscreen, access the storage, and bring up more of the hardware. So here on my board you can see those 3 holes from there. That it's my UART interface where I have ground, the X and the X. Okay, let's discuss about the wall number 2, the bootloader. This wall comes before Linux really starts, before Debian, before the desktop, before the drivers. The device has to decide one thing: will it load my code or not? On a normal PC you can usually plug in a USB stick and boot another operating system. On most Android phones and tablets it does not work like that. Many devices only boot software signed by the manufacturer. Some do this for security, some for support reason, and some because they never intended user to run anything else. That is why UART is so useful. Here you can see what the device is doing during the boot. Choose my Linux debug kernel and check if the kernel is actually being loaded. Now let's say the kernel loads and the Linux starts. That still does not mean the tablet is usable. Because now we can go to the wall number 3, the drivers. You see, even if Linux boots and still does not mean the hardware works. The display panel needs the right timings, the touchscreen needs the right IC2 configuration, Wi-Fi might need the vendor drivers or a firmware blobs. The battery, GPU, camera, speaker, suspend and resume, each of those can become its own mini project. And this is where the native Linux become really interesting. From the Linux side, I can inspect the GPIO lines, I can see the kernel, what kernel expose, and understand what parts of the board are controlled by which drivers. That is very different from running a Linux-like shell inside an Android. In Termux, Android still controls this layer. In native Linux, if the hardware allows it, I can change the device tree, change how Linux see the board, and even repurpose the hardware lines for something else. This is why running Linux natively is not just about Debian. The hard part is making the hardware usable. And this is the important part. Those 3 walls are connected. The device tree tells Linux what hardware exists and how it is wired. Without that map, the kernel is almost blind. The bootloader decides if the kernel and the device tree are even allowed to start. If the device refuses to load them, Linux never gets a chance. And the drivers, decides if the hardware becomes useful or it is just a log and does nothing. So native Linux is not one single trick, it is a chain: hardware map, kernel boot, and useful drivers. If one part is missing, the whole thing can fail. This is why one Android device may run Linux while another device with similar specs may be almost impossible. So if it is enough interest, I will turn this in a mini series: firmware extraction, device trees, kernel builds, bootlogs, and drivers. I cannot promise a regular schedule because this is a hobby, but if you want to see that, let me know in the comments.
So, can your Android device run Linux natively? Maybe. But now, you see, the real question is not can I install Debian on it. The real questions are, can it boot independently? Can Linux understand the hardware? Are there any drivers available for the important parts? And now, if you missed my first video where I show the tablet actually running Debian, I will put it on the screen. And as usual, thanks for watching, and don't forget to like, subscribe, comment, and see you in the next one.